Good evening, everyone. So we started trigonometry last week. We did a few examples based on reduction formulas. So these are the questions for reduction formula. And in grade 10, we had some basic type of example that will continue in grade 11. That will continue in grade 12. So let's do from the first question, which will remind us about grade 8's work, grade 10's work. Right? So here if I see the first question, it says, when I read further, it says without the aid of diagram. Without the aid of diagram means by using with the aid of diagram. It means I'm going to draw Cartesian plane and on that Cartesian plane we'll find a proper quarter. We draw our triangle, and for my rest of the questions we are going to use a triangle to answer this question. So it might include a reduction formula. And for triangle we are going to use SOHCAHTOA. To draw a proper triangle, let's draw the Cartesian plane. This is my Cartesian plane. It has got 4 quarters. So first one is between 0 to 90, where all the functions are positive. Between 90 and 180, only sign is positive. Between 180 and 270, cosine tan is positive, and 270 and 360 degree, cosine is positive. So this signs will help me to choose a proper diagram, proper quarter. Right? So if I read now further, cosine theta is negative 1/3. So the given information to me, cosine theta is negative 1/3. So this sign is important. So that tells me that my diagram, my triangle must have cosine negative. And then I'm going to check which quarter cosine is going to be negative. So it's going to be first, second and third quarter, where second quarter sine is positive, cosine is negative. Third quarter tan is positive, cosine is negative. So out of those 2 quarters now, one of them will be my correct answer. So for now, to choose the right one, we are going to read further. This one is called the condition. They are telling me that my theta, my triangle, my angle is between 0 and 180. So if I go and check my diagram there, between 0 and 180, it tells me either it is quarter 1 or it is quarter 2. Now I can see my more information, more diagram, more more indication goes to the second quarter. So this is my correct diagram now. Now when they give me cosine theta is negative 1/3, they are telling me it's adjacent over hypotenuse. So hypotenuse is 3, adjacent is 1. So if I'm looking for hypotenuse is 3, if I'm looking adjacent is 1. But if I see my adjacent is in second quarter, where my x value is negative. So that negative sign belongs to -1, belongs to x value, adjacent. Then we are missing y. This is my right angle triangle, so whether they tell me or not, I'm going to use Pythagoras. So if I use Pythagoras, it says 3 squared is equals to negative 1 squared plus y squared. So 3 squared is 9, negative 1 squared is 1 plus y squared. So I'll bring 1 this side, so 9 minus 1 is y squared. Therefore y is equals to square root of 8. 9 minus 1 is 8. Then I will make it square root of 8. And that's my hypotenuse or radius. Okay, once I complete the triangle, now I will go and look for question answers. So now they are telling me what I'm looking for, 5.1.1, tan 180 minus theta. So 5.1.1, my question is what is the value of tan 180? Minus theta or plus theta? It's plus theta. Plus theta. So, like we discussed, we are going to check where is this angle, 180 plus theta. So first is the reduction formula. This one, 180 plus theta, it tells me it is in the third quarter after 180. So that's theta. So in third quarter, tan is positive, and if according to reduction formula, 180 will fall away. Only remain is tan theta. Once I have a tan theta, I will use a definition of tan theta, which is opposite over adjacent. Go to the diagram. My opposite is √8 and adjacent is a -1. It's done. Then let's go to 5.1.2. 5.1.2. It says 3 sine theta minus 90. Okay. So if I look at this one, that's my right angle cartesian plane. Theta is in the first quarter, and they are telling me from that theta I will go negative 90 degree. Negative 90 degree is nothing but going back into 1 quarter. When I move back 1 quarter, 90 degree, sine is going to be negative. So my reduction formula is going to be negative. But theta minus 90, 90 minus theta, they are my co-functions. So whenever 90 and 270 is involved, it will become co-function. And whenever the co-function is there, I'm going to change my function sine into cosine theta. Then now I'll go to the diagram and substitute. What is the value of cosine? Cosine theta is adjacent. That's -1 over 3. Adjacent over hypotenuse. So -1 over 3. So if I see negative, okay, that was positive. Negative times negative is going to give me positive. 1/3 times 3 is there. So those two get cancelled. My final answer is 1. Okay. So this triangle question without the aid of a calculator, it means by use of a diagram or by use of a triangle, we are going to get few answers. So that is the first example we did. Let me take a similar example to this one, then we will go back to trinomial type of question, triangle type of reduction formula type of question. So this is the second type of question. Normally it keeps on repeating. So like we used to do in grade 10, the moment I have a triangle, I have a point, I'm going to create a triangle. So here I have 2 points. So what I'm going to do, I'm going to create 2 triangles. So if I see the first triangle, which has got a point T, that x value is x and y value is 15. Okay, so those are the 2 things I have about P. From point P, the values are -2 and a, so that means x value is -2, y value is a, by just looking at the diagram. Right? So that obtuse angle theta, I can write it inside the triangle now. It's not going to change any value. It depends. It just indicates the sign, positive or negative. If I read further, then it says OT equals to 17 units. So that's O, that's 17 units, 17 units. Now I can use Pythagoras to get the value of x. Let me use Pythagoras then. So let me start writing the Pythagoras formula first. I'll say hypotenuse squared is equals to 15 squared plus x squared. So it's 17 squared minus 15 squared, that is equals to x squared, but we are looking for x, so I'm going to take a square root both the sides. Okay. So that will give me value of x. So now let me use a calculator. It says the square root, then 17 squared minus 15 squared. I can use direct answer. So it says x equals to 8. So x equals to 8. If I look at the value of x equals to 8, x is a negative x-axis. So even though I got the value of 8, by looking at the direction of that x, negative x side, I can make that x value negative 8. Negative x, and it is the same as negative 8. Now if we look at these two triangles from grade 9, we studied about the similarity of triangles. What is similarity? Two angles are the same. So both of them, they have angle theta is the same, and both of them, they are right angles. So that means these two triangles are similar. When we have a similar triangles, we can use the ratio. Right? One triangle will be big, the other triangle will be small. To get the further answers, we are going to use the ratio. But let's keep it for now. By looking at this, I know that later on I'm going to use the ratio. So let's go to the questions then. With the aid of diagram, which we have already used, 5.1.1, value of x. Okay, so it means the moment we use the Pythagoras, we already have the first answer, 5.1.1. Now the same thing I'm going to use, 5.1.2, I'm looking for tan theta. So the moment my diagram is complete, it's SOHCAHTOA. It means it's opposite over adjacent. Finished. That's my answer. When I look at the third one, 5.1.3, cosine 180 minus theta. The moment I see 180 minus theta, it tells me it's a reduction formula. So if I go quickly, there is 180 and minus theta suggests that I must go towards less number of angle, less value of the angle. So it means it is taking me to the second quarter where cosine value is negative. So that's the first mark for doing a reduction formula. And then I will keep the negative sign as it is. Cosine theta, once again I will use the diagram. It says it's adjacent, which is negative 8, over hypotenuse, which is 17. So it's negative 8 over 17. And now if we simplify, that negative times negative will become positive 8 over 17. So the next value from the diagram is sine square theta. It is nothing but sine theta and it's squared. And sine theta, if we are looking for opposite over hypotenuse, that opposite in my diagram is 15 over 17. Opposite is 15, hypotenuse is 17 squared. So I can say 15 squared is 225, 17 squared we can use once again the calculator. So 17 squared is 289. It is 289. That's my final answer. I don't think so I can further simplify this. Now it says the value of A. So where is that A? If I look at this, it is the vertical height of a small triangle. So if I redraw the diagram on a side, so this value is, that's 15, that's negative 8, that's 17 so far. And now here we have negative 2 and A. If I can observe and get direct answer, that's fine. If I observe this one, x value is minus 2 to minus 8 times by 4. So that means small triangle to bigger triangle, I'm going to do times by 4. Similarly, if I'm looking at this vertical 15 and vertical A length, if I have to go bigger triangle to smaller triangle, I'm going to divide by 4. So the answer for value of A, I can just say 15 divided by 4. No need to simplify, that's my answer. So the similarity questions will come again and again. Right? So many times it has been asked. Let me do one more example of a diagram without the aid of calculator. It means we are going to use a diagram. Okay. So here is our another example. If I am looking at this, in the diagram, R is the point. Okay, the moment they give me a point, I will do my basic. Draw a triangle so that I can use SOHCAHTOA. Okay, there is angle alpha there, 90 degree is there. And so they are telling me TOR, so that angle O is alpha. RO is extended. So the moment one of the line is extended, it extends until P, so I can complete the triangle there. So this time also these two angles, that angle O which was there, I can say it's O1 and O2. Those are my vertically opposite angles. So I can just make it alpha here as well. Vertically opposite angles are equal. So now in these two triangles, two angles are the same. Alpha and alpha, 90 and 90. It means these two triangles are also similar. And I can use the ratio for their unknown length. Now RO extended till P, so which we have already checked, so that OP is 2 times RO. So 2 times RO. That OP length, what I have, is double of what I have it in a smaller triangle. So if I get 6, I'm going to make it 12. If I get 5, I'm going to make it 10. So let's read further again. TOP is beta. Okay, that is our reflex angle, which I can take it inside similar value of B. So B is my acute angle, which will have the same sin theta, cosine theta and tan theta value as my reflex angle beta outside. So basically any reflex angle or obtuse angle, you can go inside a triangle and change it to acute angle. Sin alpha. Now when they give me this one, the use of it is they are telling me in that triangle what is my opposite and what is my hypotenuse. So opposite is 3 and then hypotenuse is 5. So like we always do when we have a triangle and when we have two sides, we quickly going to use, okay, so I'm missing x, we are going to use Pythagoras. So I'll say hypotenuse squared is equals to side 1 squared plus side 2 squared. So 5 squared is 25 is equals to 9 plus x squared. I can take 25 minus 9, that is equals to x squared, but we are not looking for x squared. We take square root both the side, so x will give me 4. The moment I get one of the unknown values of x or y, I must check in which quarter. If it is the first quarter, both x value and y value will be positive. So I'll make it that x value is positive 4. So now when I was reading, I read is OP is 2RO. So that's OP, small triangle, which the length is 5. So if I go in the other side, the third quarter, that length will become now 10, double of it. So if I know one of the side, the ratio is 5 and 10 times by 2. So that means the rest, vertical y value 3, it will become 6. Horizontal x value 4, it will become 8. But my triangle is in the third quarter, it means my x value will be negative, y value will also be negative. It's no more 6, it's negative 6 then. Okay. So once both the triangles are complete, we can go and look at the questions. What are my questions? The value of tan alpha. So that is tan alpha. Alpha is the smaller triangle. That's alpha 3, 4 and 5. So tan alpha, if we use the definition, is opposite over adjacent, and then my answer will come out to 3 over 4. If I look at the sine beta, so sine beta, the definition, okay, that beta is now my triangle in the third quarter. That's beta. We have the values now 10. Hypotenuse can never be negative. And it is the radius of the circle, actual length. -6, -8. So for beta, we are going to use the bigger triangle. So it's opposite over hypotenuse. So my opposite value, opposite of beta is -6. Hypotenuse is 10. I can simplify equivalent fraction. It is over 3 over 5. Then the coordinates of P. Now, as we have the x value, x value is -8 and the y value is -6. That x value and y value together, it will become point P, x, y, which is in the third quarter. I should have x value negative and y value also negative, which I have it. So the ratio questions, similar triangle questions will be there in your trigonometry. So those are 3 examples which I did now. So now let's go to the reduction formula questions, which is introduced in your grade 11 this year. So I'm going to go back to the first page, page 1. So this question number 2, 5.2 is our reduction formula question. So once again, for reduction formula, we are going to draw our Cartesian plane. Let me just clear up the screen a little bit so that we have some values to write. Okay. So if I want to write my angles there, 0 is written there already. Let me reduce some writing. Okay. So 0 is there already, 90 is there. This is my 180 degree. This is 270 degree. And there is 360 degree. So the direction which I know, it's -180 minus theta. I'm going for less angle than 180. It means it will take me to the second quarter. That theta is my acute angle. If I go to the third quarter, it will be more than 180 degree. So that diagram will tell me it is the place of 180 plus theta. Similarly, the first quarter and the third quarter. Third quarter, if my theta is here, it is less than 360. It means this direction is 360 minus theta. It's just quick recap. Right? Let's see what we can do here. If I look at this one, okay, for me negative angle is a bit complicated. Let's see the easy one, what we can do. Right? So the second denominator is sine 360 plus x. So it means it's more than 360. So if I see 360 is my 0 degree as well, both of them, they are the same. Plus x means I must go anti-clockwise direction. It means it will take me to the first quarter. So that's my theta, or 360 plus theta. So the reduction formula asks me what is the sign of that angle or this angle in the first quarter, where sign I know it's a positive. So what I'm going to do, I'll go there and write my answer for the second denominator, which is positive sine x. Then another known one is cosine 300. So I'll go and look for my 300 degree. Okay, so 300 degree I know it is less than 360 So it means it will be somewhere here 300 degree. If 300 degree is here, so that means the acute angle related to that one is now 60 degree. So basically 60 degree in fourth quarter where my cosine is positive. So my writing answer for cosine 300 is positive cosine 60 degree. Now we are here. Cosine negative sine negative 210. So first of all, I need to check where is a negative theta, negative angle. So if I'm concentrating again on this diagram, if I start from basic, let me clear up the screen a little bit. So I want to start writing or want to check the angles written 0, 90. I'm going clockwise. 180 going anti-clockwise, sorry. From 180 to 270 increasing value if I'm going anti-clockwise. From 270 to 360 anti-clockwise. So now if I'm going anti-clockwise, my angles are all positive. So if in a question somewhere somehow if I'm having a negative angle, easiest to see is that I will start my journey clockwise direction from 0. So from 0 downwards now. It will be negative 90. Okay, I have to reach till 210. That's negative 180. Okay, so 210 is after 180 negative. So there is negative 210. So if I look at the counting from negative 180 to 10, I will end up with 30 degree. So in short, it is my sine 30 degree. So sine negative 210 is the same as sine 30 degree. I'm left with sine. And as I ended up second quarter, the sine of sine theta is positive. Okay. So far we out of 5 marks we have scored 3 marks. One denominator, another denominator, one numerator. Now we are left with cosine x plus 90. So let me see where is that angle. If I'm looking for x plus 90, so first of all I'll go to x, angle x, which is always the acute angle in trigonometry, angle x. So that's my angle x or theta. And what are they telling me? I must add 90 degree to it. So if I add positive 90 degree, I'm jumping from first quarter to second quarter. So if I'm in second quarter, my function is cosine and sine of cosine is negative. So I will write negative. And as we discussed, the moment I have a 90 degree, it converts my function into its co-function. So I'm going to write it as sine x. So those are my 4 marks for 4 reduction. Right? So the last mark remaining is for my final answer. Whatever I can do there in my final answer. So my calculation will start. So sine x positive, sine x and sine x cancel. Negative divided by positive is negative 1. Okay, sine 30. So if I use my calculator or if I use a diagram, I'm going to get the same answer. So let me use sine 30. So when I have a special angles, I can use a calculator. It tells me 0.5 or 1 over 2. So if I write that answer 0.5 numerator, and then let me check the cosine 60. So let me erase, check cosine 60. Okay, that is also 0.5. Okay, let me think now, why do I have the same answer? So if I see sine 30 and cosine 60, if I see Sine and cosine, their angles, if their total is 90 degree, we call it cofunctions, and cofunctions, they are equal. And so that's why on calculator also we are getting the same answer. So if I can start my cancellation, 0.5, 0.5 cancel. So I'm left with 1 minus 1. My final answer is 0. Okay. So this is our reduction formula, and reduction formula, they will be repeating exactly same as this one. The numbers will be different, method of writing the answer will remain the same. So I think we will stop here today, 5.2. So in our next lesson we will continue a few more examples of similar reduction formula and other methods. Okay. So we are done now.